We wanted to know if there was a significant correlation between a person's shoe size and their height, so we decided to conduct a correlation and linear regression test. To gather data, we asked my Facebook friends for their shoe sizes and heights, and 90 respondents gave us their information, so our problem is as followed. Researchers want to know if a person's height can predict the size of shoe they wear. Taking a sample of 90 adult men and women, as shown on the tables here, the researchers converted all reported shoe sizes to women's sizes in order to create uniform data, and converted all heights in feet to inches. So a men's shoe size of 10 is a woman's 11.5, and 5'3" equals 63 inches. Using alpha equals 0.05, can it be determined that a person's height in inches and women's equivalent shoe size have a significant correlation? So now that we have all of our data plugged into lists 1 and 2 on our TI-84 calculator, we are going to find the slope for problem A of part 1. The slope formula is b equals n times the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x squared. So now we're going to use our calculator and go to 2 of our stats. And to get there, we are going to go to the stats menu and go over to calculator and hit 2 var stats. So hit enter, and in this menu you find all of the numeric values you need to plug into the equation. So now that becomes 90 times 53,812.875 minus 5,913 times 807, and remember to put in your parentheses for your calculator input later when you go to double check, and that's all over 90 times 391,217.375 minus 5,913 squared. Those are some big numbers. So the easiest way to find the slope or b value is to go to LinReg t-test on your TI-84. And that's found under the stats menu, scrolling over to test. But this equation is a really good way to double check your answer. So by using LinReg t-test, we got b equals 0.2901. And here we are confirming that in LinReg t-test, which is F on your TI-84 test menu under stats. There we go. Scroll down and we've got our b value. Excellent. So now for question B of part 1, we are going to find the y-intercept, or our a value. Now again, the easiest way to do this on your calculator is to go to LinReg t-test, and that'll give you your a value. But the equation for it is a equals y bar minus b x bar. And since we used LinReg t-test and the equation in the previous question to find our b value, we now can plug that into our equation here. So it becomes 8.9667 minus 484,319.352 times 65.7. And that gives us our a value of negative 10.0942, which we confirmed on LinReg t-test. For problem C, we are going to write out the estimated regression equation. So we're going to use the format y hat equals a plus bx, where x is our value for height. And so that's going to be y hat equals negative 10.0942 plus 0.2901x. And that's all you have to do for that one. now we're going to find the standard error of estimate, and the equation for that is S equals the sum of y squared minus a times the sum of y minus b times the sum of xy over n minus 2 all under the square root. And the standard error of estimate is the standard deviation of the residuals on a linear equation or a least squares regression line. The closer the number is to 0, the more linear it is, so you want the number to be as small as possible because that means that there's more of a significant correlation. So we had originally made a calculator error when we were trying to find our S value. When you're using the calculator, use LinReg t-test to find your S value and not the TUVAR stats menu where it will give you the value of SX. You want to use LinReg t-test on this particular type of test because that will give you the proper S value. We had to double check our answer by doing it completely by hand in the calculator, and that's how we double checked. So that was one difficulty that we ran into, but we solved it pretty easily. So when I plugged the sum values in from the TUVAR stats menu, we got 7,792 minus negative 10.0942 times 807 minus 0.2901 times 5,382.875 over 90 minus 2. So that gave us an S value of about 1.9243. And that is also what we got on our calculator when we used LinReg t-test. So now we're on to part 2 of the problem, and this part is to test to see if height is a good predictor of a person's shoe size. So for problem A of part 2, we're going to find the correlation coefficient. On the calculator, we find this by going to the stats menu, going over to tests and hitting F for LinReg t-test. And our correlation coefficient is R, which for us equals 0.6433. So now we are going to find and interpret the coefficient of determination, which can again be found on our calculator by going to LinReg t-test, and it's just our R value squared. So it is 0.4138. So our coefficient of determination is the correlation coefficient squared. And our interpretation of that is that approximately 41.4% of the variation in a person's shoe size is explained by the least squares regression of their height. So now we are stating our hypotheses, and our null hypothesis is that rho is equal to 0, meaning that there is no significant correlation between height and shoe size. And our alternative hypothesis is that rho is not equal to 0, which is our claim, and that means that there is a significant correlation between a person's height and their shoe size. So now we're going to draw a number line and label the endpoints and critical values based on a 5% level of significance. And so on our calculator, we're going to go to Program and hit CVR and plug in our sample size of 90, our alpha of 0.05, and this is a two-tailed test. So our critical values are plus or minus 0.072. So again, on the TI-84 calculator, you're going to go to Programs and then CVR to find the critical value for your correlation coefficient. So for us, that was plus or minus 0.2072, and now we're going to draw and label our number line. So we're going to start by putting the 0 in the middle and labeling our positive and negative critical values. So negative 0.2072 and positive 0.2072. And those are going to be our shaded rejection regions. So because R, our correlation coefficient, is 0.6433, that means that it falls within our rejection region. So here we have R equals 0.6433, and that's bigger than 0.2072, so we are going to choose to reject the null hypothesis. To summarize our findings, there is enough evidence to suggest that there is a significant correlation between a person's height in inches and their women's shoe size equivalent. So now we're going to use the regression equation to predict the shoe size of a person who is 67 inches tall. So that is 5'7". To summarize, so we're going to be using the same regression equation that we discussed on the first side of this worksheet. So that's y hat equals a plus bx, and for us, we're going to plug in our values. So y hat equals negative 10.0942 plus 0.2901 times 67, where 67 is our x value and the height of a person in inches. So we're plugging that into our calculator, negative 10.0942 plus 0.2901 times 67, and we are going to get a value of 9.3425. So we're going to, again, we've plugged our information into the regression equation to predict the shoe size for a person who is 5'7" or 67 inches tall. And we've gotten a y value of 9.3425. So because there is no shoe size of 9.3425, we went ahead and interpreted this as a person who is 5'7" or 67 inches tall is estimated to wear around a woman's size 9 shoe, accounting for variation. So there you have it. Based on our calculations, we were able to determine that there is enough evidence to suggest a significant correlation between a person's height in inches and their women's equivalent shoe size. So thank you for taking the time to watch this video, and thanks to everyone who participated. We hope you learned something interesting. Bye.